Hello, this is Meaningless Coding. Today we are going to study about Azure Cosmos DB. And I am going to paste the content as much as needed, okay? I'm reading it from Microsoft Learn website. Yeah, maybe it's better to read it directly from there. Okay, it's okay. Give me a second. Here it is. We are exploring Azure Cosmos DB. If you go to the training section of the Cosmos DB, you will find some steps. This is one step of my study. We will focus on this step to learn exploring the Azure Cosmos DB in this video. So let's start with identify key benefits of Azure Cosmos DB. I will try also to take some notes beside reading, sometimes repeating probably. Beside that, I will try to take some notes. Please try to keep up with me. At the moment, let's copy that one and put it as a label, Azure Cosmos DB. Yes. Another. I think I am logged out from my note taker. Sorry again. I will start in a second. Very good. Let's take this title as a first section. Azure Cosmos DB is a fully managed NoSQL database designed to provide low latency, elastic scalability, and throughput, well-defined semantics for data consistency and high availability. So, the key benefits of it, the data consistency, of course, and high availability. Of course, you have to select some parameters in order to achieve that. Well-defined semantics, but I don't believe we need that. Yeah, this is not developed storage, so maybe it is needed. fully managed NoSQL database designed to provide low latency. Okay, there are a couple of tiers, I know, and sometimes it can be laggy, and don't say to me low latency. Elastic scalability of throughput. Well-defined no, these are not schemas, huh? Semantics. Let's well-defined semantics. Let's see why. What does it try to say? Refers to price and unprecise and unambiguous meaning of expression statement with the system. Typically in the context of programming languages, logic and formal system. In more details, semantics is about what something does or represents rather than just how it's written. Well-defined mean clear. Okay. Guys, just compliment. You can configure your database to be globally distributed and available in any of the Azure regions. To lower the latency, place the data close to your users are, where your users are. Choosing the required regions I'll try to, yeah, maybe this is better now. Is it better now? This is better. Which one is better? This one is better? Okay. I will try to read a bit loud, but I don't want to do it, because I don't like speaking too much. My throat is not used to it. It's not built for it. With Azure Cosmos DB, you can add or remove regions associated with. One sec. I have to start Pomodoro. This time it's Azure Cosmos DB, right? Project, yes. You can add or remove regions associated with your account at any time. Region, you can't add or remove regions. This is interesting. Normally you have to select a region while creating a resource and it doesn't change, but this time with Azure Cosmos DB you can add or remove the regions associated with your account anytime. Your application doesn't need to be paused or redeployed or this is very good. I have to take this down. It's novel multi-master application protocol. Wow, novel. Every region supports both writes and reads. Okay, multi-master capability also enables unlimited elastic write and read scalability. The multi-master capability also enables unlimited elastic write and read. Yeah, but no, it doesn't. Yeah, what's the relation with the multi-master capability and elastic read and write? 99.999% read and write availability all around the world. Yeah, this is more than VMs. Actually, VMs, I believe, just until here, or maybe until 1 digit. Guaranteed reads and writes served. We should take this number, note it down. Availability 99.99939. Guaranteed read and writes served in less than 10 milliseconds at 9th percentile. Okay, let's continue. Your application can perform near real-time reads and writes against all the regions you choose for your database. Azure Cosmos DB internally handles data replication between regions with consistent level guarantees of the level you selected. Running a database in multiple regions worldwide increases the availability of the database. If one region is unavailable, other region automatically handle application requests. Azure Cosmos DB offers availability for the multi-region databases. This is for multi-region. Okay, what I understood is the Cosmos DB is capable of running across multiple regions. This flexibility or elasticity brings benefits of the availability. Okay, explore the resource let's okay, I don't need to take it. Explore the resource hierarchy. The Azure Cosmos DB account is the fundamental unit of global distribution and high availability. Your Azure Cosmos DB account contains a unique domain name system name, and you can manage an account by using Azure Portal, Azure CLI, or by using different language specific SDK for globally distributing your data and Throughput across multiple Azure regions. You can add or remove regions to your account anytime. You told me already, man. Elements in an Azure Cosmos DB account. I want to learn more about this. Cosmos DB account contains unique domain name system. Okay. If it doesn't tell me, we will search for it. An Azure Cosmos DB container is the fundamental unit of scalability. Azure Cosmos DB container, the core of the DB. Then container probably it's represents a table or something. You can virtually have an unlimited provisioned throughput and storage on a container. You can virtually have unlimited provisioned throughput and storage on a container. Azure Cosmos DB transparently partitions your container using the logical partition key that you specify in order to elastically scale your provision throughput and storage. Currently, you can create a maximum of 50 Azure Cosmos DB accounts under an Azure subscription. Can be increased via support request. After you create an account under your subscription, you can manage the data in your account by creating databases, containers, and items. Yeah, the container is probably a table or a collection or this kind of stuff. You put items in it, and then the containers are placed in the databases. The following image shows the hierarchy of different entities in an Azure Cosmos DB account. This is the account, databases, yes, containers, stored procedures. Okay, this is important. User-defined functions, triggers, merge procedures, items, conflicts. What is conflict? Defining on the Cosmos DB API, containers are realized as a collection, table, graph. Okay. Depending on the Cosmos API, an item is realized as document, row, node, edge. Very good. Let's take this down. Database account is bigger than database. Database bigger than container. Container bigger than item. And container consists of items, stored procedures, whatever, procedures, user-defined functions. Yeah, stored procedure and a user-defined function. Look like a same to me, man. User-defined function. UDFs, stored procedure in Cosmos DB. Both allow you to create custom logic, but they serve different purposes and have distinct behaviors. Okay. User-defined functions. Purpose. Extend the query language with custom logic. Used with SQL queries to compute values. Example, select. This is a function. Uppercase. Okay. A stateless JavaScript language, JavaScript. Interesting. Side effects. Cannot perform write, read, and update to the database. Performance. Example usage. Stored procedure. Run multi-step logic or transactional operation on the documents. Language, again JavaScript. Side effects. Can read, write, update, delete documents. Supports transactions even. Let's take this down. Reusable logic in query. User-defined functions. Transactional logic. Read, update, delete. Stored procedure. Multi-document operations in partition. Okay, I think I got the difference. So basically, the logic, the functions are some tools to update the values, like this one. The name makes the name uppercase, and this is probably the predefined function, but probably then I assume you can also define some functions somewhere and put them in the container. And stored procedures are predefined, not predefined, but also user-defined statements, like query combinations, probably. Then you pass parameters into them, then you run, update, read, write, and stuff like that. Continue. Triggers. Okay. Triggers. Probably the triggers are listening the table container updates or something. It's in container. Yeah. Before or after hooks. Before and after a database operation performed, like insert, replace, delete. How to implement the custom business logic, validation, and side effects associated with the document changes. For example, pre-trigger, validate documents before write operation. Post-trigger. This is very good, interesting. You can program the database like normal application. It's very powerful, I think. When to use triggers. Enforce custom validation. Audit timestamps or metadata. Add. Okay. Log changes or send notifications. Log changes. Okay. Mass updates or batch writes. Use stored procedures instead. Why? Execute code during query. Use UDFs instead. Execute code during query. For reading, I mean. Triggers. Insert, replace, delete. Then it means not for read operations. Execute. It doesn't execute UDFs instead. Why not for read operations and mass update and batch writes? Don't support read operations. This is by design, and there is why. Triggers are meant for data mutation operations. Okay, let's skip it for now. Not good for triggers are not for then. Let's take this table, save it. only for triggers or only for data manipulations. And not for batch. Items, merge procedures, stored procedures, and merge procedures. What is merge procedure? The term merge procedure can mean different things depending on the context. Okay, but generally it refers to a process or operation that combines two or more sets of data. Okay, merge into. Why they are separately mentioned in Cosmos DB. In relational databases. In Cosmos DB, doesn't have a built-in merge operation like SQL. However, you can simulate a merge procedure using stored procedures. So in Cosmos DB, merge procedure typically means a stored procedure that merges data into container by absorting or SDK codes. Yeah, okay. Some manual job, huh? Okay, take this down, merge procedures. And finally, conflict. Conflict. What is conflict? Under the scope of Cosmos DB container. Write conflict that occurs during multi-region applications, specifically when conflict resolution is required. This can happen when the same item is modified concurrently before application completes. Okay, this is a conflict in Cosmos DB. What is a conflict? I got it, man. Example scenarios. Okay. Resource. Ooh, that means all conflict resolution settings apply to the entire container. You cannot configure conflict resolution at the document level. I think you can access conflicts using SDK. Summary. A conflict in Cosmos DB happens during multi-region, multi-master writes when the same document is updated. Resolved by last write wins. Default last write wins. Custom stored procedures or manual feed processing. Conflict resolution is configured at the container level. Okay, then you can write some code maybe then to eliminate the conflicts. In the Cosmos DB, the phrase storing conflicts in the container usually refers to enabling a feature where conflicted writes are persisted and accessible through a conflict feed on the same container. conflicts occur, the Cosmos DB can persist those conflicts instead of discarding the losing version. These conflicts are stored alongside the container data, and you can access them later in. Okay, using conflict feed. Okay, I got it. Then they are not the functions, but the other version of the item, which is discarded or can be discarded. This allows inspection of the conflict document, manual, programmatic resolution. Okay. Good. Let's continue then. You can create one or multiple Azure Cosmos DB databases under your account, and database is analogous to a namespace. Yeah, I know that. The database, just a namespace for your collections. Database is the unit of the management for a set of Azure Cosmos DB containers. Yes. Table, collection, whatever. The DB containers. Most relation databases, unlike most relation databases which scale up with larger sizes or virtual machines, Azure Cosmos DB scales up a bit larger sizes of virtual machines, scales out. Okay. Data is stored on one or more servers called partitions. Yes, partitions. I heard about that somewhere here. Where is it? Not here then. Okay. Whatever. More servers called partitions. Okay. Then, what I understand, you have the partitions in container level, and those partitions are separate servers. To increase partitions, you increase throughput. In order to increase partitions, you increase throughput, or they grow automatically as storage increases. The relationship provides a virtually unlimited amount of throughput and storage for a container. When you create a container, you need to supply a partition key. Okay, the partition key is a property that you select from your items. The partition key is a property that you select from your items. To help Azure Cosmos DB distribute the data effectively across partitions. Okay, just a group idea or something. You can define, then you put that group in one server, the other one into another server. The Azure Cosmos DB uses the value of this property to route data to appropriate partition to be written, updated, or deleted. You can also use the partition key in the where clause in queries for efficient data retrieval. Okay, if you know where is your data is, then you can use that partition key. The underlying storage mechanism for data in the Azure Cosmos DB is called a physical partition. Okay. Physical partitions can have a throughput amount up to 10,000 request units per second. Okay, yeah, it's not unlimited then, eh? Where was it? Unlimited. Virtually unlimited amount of throughput. But it says relationship provides, not the partition. Let me drink some water. Okay, continue. Physical partitions can have a throughput amount of up to 10,000 requests. Let's take this down. Note it down, okay? And they can store up to 50 gigs of data. Okay, then one server have 10,000 request unit per second and 50 gig of data. Okay, let's say one CPU or two CPU attached with this 50 gig of SSD. Let's say Azure Cosmos DB abstracts this partitioning concept with logical partition, which can store up to 20 gig of data. 20. Okay. Logical partitions store 20 gig of data. Why is that, man? When you create a container, you configure throughput in one of the following modes: dedicated throughput, shared throughput. Yeah, I know a little bit about this. The throughput on a container is exclusively reserved for that container. There are two types of dedicated throughput: standard, autoscale. Okay. Shared throughput is specified at the database level and then shared with up to 25 containers within the database. Sharing of throughput excludes containers that are configured with their own dedicated. Okay, if you have already configured one container with some dedicated throughput, then even if you define some shared throughput in the database level, then those already set up containers cannot use the shared throughputs. Okay, 25, huh? Depending on which API you use, individual data entities can be represented in various ways. Cosmos DB entity, Cosmos DB item, API for item row document or blah, yeah. Okay, I want to take this reserved exclusive for a single container. Two modes, standard and autoscale. Shared throughput allocated at the database level, shared by up to the level contains with the Okay, I will put it to complete the thingy here. Very good. Yeah, this is the item, Cosmos DB item. Now we started with the database, then container, now it's item. For NoSQL databases, it's item. For API, Cassandra, it's row. For relational document databases, it's row. Gremlin, it's not. For Mongo, it's document. Also for other. NoSQL database for other and NoSQL databases. It's documents. Azure Cosmos DB approaches data consistency as a spectrum of choices instead of two extremes. Strong consistency and the eventual consistency are at the end of the spectrum, but there are many consistency choices along the spectrum. Developers can use these options to make precise choices and granular trade-offs with respect to high availability and performance. Azure Cosmos DB offers 5 well-defined levels from strongest to weakest. The levels are strong, bounded staleness, yes, session consistent prefix eventual. Each level provides availability and performance trade-offs. The following image shows different consistency levels as a spectrum. Okay, we will dive into it one by one, probably. The consistency levels are region agnostic. Okay, very good. And are guaranteed for all operations. Regardless of the region where the read and writes are served. The number of regions associated with your Azure Cosmos DB account. Number of regions. Okay. Whether your account is configured with a single or multiple write regions. Yeah, so far I heard a lot of compliments about the Cosmos DB. We will see, man. We will see if you are worth it. Okay, my Pomodoro stopped. I think I have to give a break. Let's finish this section. Read the consistency applies to a single read consistency. Okay, applies to a single read operation scoped within a partition key range or a logical partition. What does it mean? Read consistency. Read consistency, huh? Let's say there are multiple versions in the distributed regions, across regions, right? Distributed, not the distributed actually. It's only one value cloned in the regions, and then you want to read, but the other one can be changed meanwhile. But look, read consistency applies to a single read operation scoped within a partition key range or I couldn't get it. Okay, if you get it, it's okay, but I couldn't get it. Support API, discover request unit, exercise, blah blah. Where is that? Okay. I don't see that are being yeah, individually mentioned here. Okay, let's give a break. Yes, let's continue. Now we are going to learn the consistency level all the consistency levels. Let's say, okay. Let's save the latest changes I do on my note-taking application. Then choose the right consistency level. Each of the consistency models can be used for specific real-world scenarios. Each provides precise availability and performance trade-offs backed of comprehensive SLA. The following simple considerations help you make the right choice in many common scenarios. Configure the default consistency level. You can configure the default consistency level on your Azure Cosmos DB account at any time. The default consistency level configured on your account applies to all Cosmos DB databases. Then you are supposed to choose a consistency level for each database then. Let's take this note down. Consistency level for each database. Choose or set default at Cosmos DB accounts level. Okay. Read consistency applies to a single read operation scoped within a logical partition. The read operation can be issued by a remote client or a stored procedure. Single read consistency. Single read operation. Logical partition. Okay. I think I understand a bit why they say that. The read operation, because read is not they designed the read operation so that that operation that operation doesn't care the other replicas, because the write operation you have to care also the other replicas. When you change this part, then you have to change the other replicas and others, maybe multiple, maybe only one, but if it's not only one, then you have to change the others too. But if it's a read operation, you don't care if this value in this instance of the Cosmos DB, or let's say partition, in this partition, right? Read consistency applies to a single read operation scoped within the logical partition. Yes. Even it's not a physical, it's a logical. Each logical partition, there could be multiple replicas of that value, but even some of them can be different. Maybe you have changed recently, but some replicas are pointing still to the old values. But the read operation doesn't care about it. It doesn't read the other replicas values and aggregate them or yeah, choose one of those. No. It just reads from one of them, and that's it. It's scoped within the logical partition. The read operation can be issued by a remote client or a stored procedure. Okay, stored procedure. Triggers, right? Triggers doesn't have a read operation, but stored procedures has read. Okay. Guarantees associated with consistency levels. Guarantees associated with it. Okay. Which consistency level guarantees what? This is what we are going to learn. Azure Cosmos DB guarantees that 100% of read requests meet the consistency guarantee for the consistency level chosen. The precise definition of 5 consistency levels in Cosmos DB using TLA plus specification language are provided in the Cosmos TLA GitHub repository. What is TLA, man? Cosmos DB using TLA. What is TLA? High level TLA. 3, 4, 5 consistency levels offered by Cosmos DB. Customers of Cosmos DB can associate any number of regions, yes, to their Cosmos DB database at any time. Clients can read and write locally within any of the regions associated with the chosen database. Here is the description of consistency guarantee provided to clients. Cosmos DB allows developers to choose between well-defined consistency models along the consistency spectrum: strong bound to staleness, session, consistent, prefix, and eventual. Cosmos DB has operationalized and exposed them to the developers. Yeah, with a clear semantics. Yeah, on it. Performance, availability, trade-offs, and backed by comprehensive SLAs. Consistency level, linearizable reads. Okay, but why do we know? What is this TLA? Three-letter acronym, TLA. Temporal logical affections. a formal specification language. Used to design and verify complex distributed systems. Interesting. Throughput, latency, availability, unofficially. Throughput, availability. Temporal, logic of actions, formal specification language. Used externally to model Cosmos systems. It's interesting. It looks like a tool to manage these consistency and availability. What they say, the precise definition of the 5 consistency levels in Azure Cosmos DB using TLA. Definition of the levels. Specification language are provided. This is interesting. Describing the consistency levels in English is prone to errors due to ambiguity of natural language and generalizations involved. In this document, we use TLA to specify the consistency guarantees precisely. TLA is a tool for specifying distributed algorithms, protocols, mathematically and model checking them of correctness. The Cosmos DB engineering team heavily relies on TLA for specifying distributed algorithms and protocols mathematically and model checking them for correctness to verify the design decisions and address the corner case induced by concurrency and faults. Here is a recent video interview of Dr. Leslie Lamport describing this. I don't know how to pronounce this, sorry. Describing the application of TLA in Cosmos DB. Okay. Although Cosmos DB is a global distributed database, it provides the user with a single logic system image of all of their global distributed data. The specifications we provide in this document focuses on the client's interactions with their global distributed Cosmos DB database. A single logic entry by performing writes and reads based on the consistency level specified. We refrain from modeling the Cosmos DB internals and model blah 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 blah. Okay, this is just the documentation, huh? TLA. Okay. Strong consistency. Strong consistency offers a linearizability guarantee. Strong. Linearizability refers to serving requests concurrently. The reads are guaranteed to return the most recent committed version of an item. A client never sees an uncommitted or partial write. Users are always guaranteed to read the latest committed write. Okay. This means if you write the value somewhere in some partition or whatever, one place, the replicas, when you read it from a replica, then you will get the correct value, the updated value. This is the strong consistency. Let's copy that one and ask ChatGPT to create a table, and then we will understand better. We don't need this. Close. Yes. Yes, let's see. Linearizability. Okay. Guarantees. Staleness control. Use case ideal for strength. Strongest. Staleness control. What is staleness control, man? All consistency levels replicate writes to. For replicas. Okay, what is staleness control? In Azure Cosmos DB, this concept applies specifically to the bounded staleness. Where is it? Bounded staleness consistency level, where you can explicitly define how far behind the data you are reading can be from the latest write. Okay. In a globally distributed system, data updates happen in one region. Other regions receive those updates with some delay. Yes, that control allows you to bound or cap that delay, ensuring your app never sees data older than a certain limit. How it works in Cosmos DB. When using bounded staleness consistency, Cosmos DB lets you define two limits for controlling. K, version based, the maximum number of versions writes a replica can lag behind. Okay. T, time based, the maximum time interval reads can be behind the latest write. Okay. Control parameters. Cosmos DB ensures that the reads will never be older than the lesser T seconds. I got it. Let's continue then. We only apply it to this one. Others doesn't have that feature. Or staleness, bounded staleness. Okay. In bounded staleness consistency, the lag of the data between any two regions is always less than a specified amount. Yeah, that specified amount, k. The amount can be k versions or t time intervals, whichever is reached first. In other words, when you choose bounded staleness, the maximum staleness of the data in a region can be configured in two ways, k and t. Bounded staleness is beneficial primarily to single region write accounts with two or more regions if the data lag in a region determined per physical partition exceeds the configured staleness value. If the data lag in a region determined per physical partition. Okay, for physical partition. And the data lag if the data lag in a region exceeds the configured staleness value, okay, let's say t is 5 but the lag is 6, writes for that partition are throttled okay, lag is big. If the lag is big enough, or lag bigger than the set value, but if it's not possible to write in 5 seconds because there's a lag, 6-second lag, but you say I want it in 5 seconds. No, not possible. Writes for that partition are throttled until staleness is back within the configured upper bound. Staleness is back within the configured upper bound. No, then it stopped the write operations. Partition are throttled until the staleness is back. Oh man, this is interesting. For a single region account, okay, bounded staleness provides the same write consistency guarantees as session and eventual consistency. Yeah, it's not beneficial though for a single region. Because it says a single region account bounded staleness provides the same consistency guarantees as session and eventual consistency. Session, okay. With bounded staleness, data is replicated to a local majority, 3 replicas in a 4 replica set in the single region. Okay, we got it, 4 replicas. Local majority. What I remember from redundancy, not the consistency, but redundancy. Okay, whatever. It was 3 replicas, but here it says 4 replicas. With asynchronous replication to all other less or less something. Why does the Cosmos DB create replicas in the same region, and where are they stored? Cosmos DB maintains 4 replicas per physical partition. In a single region replica for where one replica acts the leader primary rights, 3 replicas are followers. Okay? This setup ensures one or more replicas fail. Cosmos DB consistently fail over another local replica. Your application remains high available even during hardware failure updates. Okay. Cosmos DB auto manages quorum among the replicas, usually 3 out of 4. Commit writes and serve read reliable. Let's ask what about redundancy? LRS. Excellent follow-up. So let's look at locally redundant storage and how it relies to Cosmos DB's internal. What is LRS? Locally redundant storage. LRS stands for the locally redundant storage in Azure. It's a storage level redundancy option. Storage level. Yes, also Cosmos DB also has storage, right? Okay, this is provided by Azure storage, not specifically the Cosmos DB. Okay, but the concept is important for understanding data durability. LRS replicates your data 3 times within a single data center or availability zone in a single Azure region. This ensures protection against hardware failures, blah blah blah. But no geo-redundancy. Cosmos DB vs LRS are the same? No, they are different concepts, but both involve data redundancy. Purpose: data consistency, storage durability, 4 replicas, physical partition, 3 replicas within a storage scale unit. Location: same region across fault domains, same data center or availability zone. Maybe multiple data centers then, or availability zone. Yeah, I know the LRS. If it's not LRS Z or ZLRS, then it's same data center. But this is same region. Applies to Cosmos DB data engine. Okay, let's skip this. Let's go with the session consistency. In this session consistency within a single client session, I am a user, I have created a session, I am writing, reading, writing again. The reads are guaranteed to honor the read your writes, and writes follows reads guarantees. This guarantee assumes a single write session or sharing the session token for multiple writers. This guarantee assumes a single writer session or sharing the session token for multiple writers. Like all consistency levels, weaker than strong writes are replicated to a minimum of 3 replicas in the local region, with async replication to all other regions. Async replication. also single region. This is probably sync. Okay, the fourth one, consistent prefix. Consistent prefix consistency. Inconsistent prefix updates made as single document writes. See eventual consistency. Updates made as single document writes. See eventual consistency. Yeah, I couldn't get it. I will read multiple times. I told you I will repeat and repeat it until I understand. Inconsistency prefix. Okay. The updates made in a single document. Okay, let's say we change an HTML file. Those updates writes document writes. Updates made as a single document writes. What kind of update can be then? I don't know, man. A single document. Like one row. Okay. Made as a single. Okay, let's say one single document update. I got it. Not a bulk one or document writes, but only for writes. See eventual consistency. Updates made as a batch within a transaction are returned consistent to the transaction in which they were committed. Okay. Inside the transaction in which they were committed. Write operations within a transaction of multiple documents are always visible together. Okay, understand. Okay, you cannot see the first document until the transaction is until transaction completes. Assume two write operations are performed on documents doc1 and doc2 within transactions T1 and T2. When client does a read in any replica, the user sees either doc1 version 1 and doc2 version 1 or doc1 version 2 and doc2 version 2 within transaction T1 and T2. Okay, yeah, makes sense. Never doc1 v1, doc2 v2, or doc1 v2 and doc2 v1 for the same read or query operation. Yeah, that's the nature of interaction in transactions, right? But okay, even it says even let's say the transactions are started at the same time. The first one is completed, but this says the second one will not see the update until the transaction completes. Okay, consistent prefix consistency. title is loose, I think. Eventual consistency. Okay, let's see the table. What does it say about the prefix consistency? Session. We got the session already. Yeah. Consistency prefix. Reads, return, ordered, writes. Ordered writes. This is also important, right? Yeah. No gaps or out of order reads. No gaps or out of order reads. Event stream processing batch writes that must stay in order. Use cases. Okay, use cases are very important. Let's continue with eventual consistency, then we will come up for use case scenarios. In eventual consistency, there is no ordering guarantee for reads. Okay, there's no ordering guarantee. In the absence of any further writes, the replicas eventually converge. Yeah. Eventual consistency is the weakest form of consistency because a client might read and values that are older than the ones it read before. Interesting. Yeah, maybe the second, maybe the following change happened first than the previous one. Eventual consistency is ideal where the application doesn't require any ordering guarantees. Examples include count of retweets, likes, or non-threaded comments. Examples include count of retweets, likes, or non-threaded comments. Okay. No ordering guarantee. Reads, return ordered writes. Okay. The transactions are basically the different users' actions. So it looks like a session, but session, read your writes. Writes follows read within the session. Okay. This is not long as a session in terms of time duration, but this is more granular, more granular. Okay. Next. Okay, now let's search for Cosmos DB consistency levels. There was another. Yes, this one. Another one. Another description. I think this is better than other one. This is more of a summary. Consistency levels in Azure Cosmos DB. Very good. Yes. Oh, okay. Distributed. Okay, let's start to read. Distributed databases that rely on replication for high availability, low latency, or both, must make a fundamental trade-off between the read consistency, availability, latency, and throughput. Let's summarize this, man. I don't have enough power to read everything. Okay, Cosmos DB supports 5 consistency levels. Strong, bounded, staleness, yeah, we know all of them. Consistency levels guarantees. Guarantees, we didn't read the scenarios, right? Is this also include scenarios? No. Let's read first the scenarios. Oh, come there. Strong. Critical data consistency, financial transactions. Okay. All the replicas should be same before anybody reads. Very good. Bounded staleness. Global apps with tolerable delay, better than eventual session. If you know, if you can tolerate one read or whatever, I don't know, man. I write 5 and another one reads the old one. It can be, yeah, it can be okay. It can be okay in some cases, like streaming applications. It's like chat messaging something. Then doesn't matter if you have 5-second delay or doesn't matter if the second or third or consecutive following read will get the latest, because whenever it reads it will get a new value. Yeah, I think messaging applications can use this one. Most apps with a single user or session-based interactions. Most apps with a single user. Single user applications. Possible. Or session-based interactions. Yeah, depends on the business case, I think. Yeah, consistency in the session. Consistency prefix. Event stream processing. Batch writes that must stay in order. No gaps. Also messaging application, I think this fits better with messaging applications, because yeah, it doesn't matter how many times you are behind, but in some applications maybe you want to specify the delay. Eventual non-critical data, yeah, like asynchronous applications, updates, websites sometimes. Yeah, makes sense. Let's see the summary again from this side. Always latest commit, reads are within defined KT. Yeah, read your writes. Write follows read within session. Read your writes. I got this part. Write follows read within session. Write also follows read, huh? No out of order reads. Okay, ordering guaranteed. This also guarantees ordering. This one also, this one also, this one also. Eventual within transaction scope. Is it eventual in the transaction scope? Come on, it shouldn't be like that, man. Eventual within transaction scope. We never heard of it. Did we? Updates made as a batch within a transaction are return consistent. Okay, if you say so. Eventual, no ordering guarantee. Write quorum. Quorum. I don't know how to translate this. How to pronounce this? Quorum. Global majority. Local minority. RPO, multi-region. No data loss. KT. 15-minute delay. 15 minutes. How reads work? Note this down. Eventual within transaction scope, huh? What? Strong and bounded staleness. Read from two replicas. Minority query. Huh. Wow, this is interesting. This is interesting. Session consistent prefix and eventual read from one replica. This should be noted. These are reading from two replicas and compare them. Huh? Default vs per request consistency. Default vs per request consistency. Default. You can set a default consistency level at account level. You can override it per SDK request. Only affects reads. This is changing default consistency requires recreating SDK clients to take effect. Okay. Replication quorums. Every region has 4 replicas per partition, 1 leader, 3 followers. Writes require majority, 3 of 4 acknowledgements. Okay, multi-region replication is asynchronous unless using strong. Yes. Dynamic query ensures write availability by temporarily removing slow regions. Multi-region limitation. Strong is not allowed for multi-region accounts. Limitations. For multi-rights region accounts. Multi-right region accounts. Okay. Is blocked by default for accounts spanning 5,000 miles due to the high latency. Throughput is higher for strong and bounded staleness due to 2 replica reads. Yeah. Data durability. This is a very good summary table. Huh? Performance, lowest, medium, high, highest. Lower availability. Lower performance, availability, medium, high, highest. RPO, multi-region. RPO, what is RPO again? Data durability. No data loss. Okay. KT, use cases, financial systems, special feeds, collaborate tools, user profiles, shopping carts. Yes. Social feeds, logs, telemetry, likes, counters, non-threaded comments, non-threaded. Okay. Strong, medium, low, or high, medium. I want this. It's similar to our previous one. However, even though I want to have it, maybe I can drop some columns, huh? Drop column availability and use case from summary table. Yes, this is better. Critical data consistency, financial transactions, yes. Social feeds, collaborative tools. What did the other one say? Global apps with tolerable delay, better than eventual, blah blah. Okay, let's take those two. User profile, shopping carts. Session. Logs telemetry. Batch writes that must stay in order. Event streaming processing. Batch writes that must stay in order. Logs has to be in order. Telemetry. Yeah. The other one likes counters, non-threaded comments. Very good. Now we can continue with this one. Okay. Or do we want to keep it here? Alright. Azure Cosmos DB offers multiple database APIs, which include I forgot to run the Pomodoro, but I feel a bit tired again, so I will just pause now and continue. Okay, let's continue. Yeah, I think I know it's weird. You just hear me. I'm pausing, then let's continue. It's weird. I know. I will try to just skip that part. If I give break again. Okay. Cosmos DB offers multiple database APIs, which includes NoSQL, MongoDB, Postgres, Cassandra, Gremlin, and Table. By using these APIs, you can model real-world data using documents, key value, graph, column, familiar data models. These APIs allow your applications to threads Azure Cosmos DB as if it were various other database technologies without the overhead of management and scaling approaches. Cosmos DB helps you use ecosystem tools, skills, all what they have for data modeling and querying with its various APIs. All APIs autoscale, storage, throughput, scalability, performance guarantee. There is no best API and you can choose any one. Consideration when choosing an API. API for MongoDB, Postgres, Cassandra, Gremlin, and Table implements the wire protocol of open source database engines. Wire protocol. These APIs are best suitable if following conditions are true. If you have existing MongoDB, Postgre, Cassandra, Gremlin applications, if you don't want to rewrite your entire data access layer, if you want to use the open source developer ecosystem, client drivers, expertise and resources for your database. What is wire protocol? Wire protocol refers to the low-level format and rules for communication between a client and a server, specifically how data is structured, sent and received over the network. In simpler terms, it defines how clients talk to databases over the network, like a language they both understand. Okay. In Cosmos DB context, Azure Cosmos DB supports multiple APIs, emulating the wire protocol of those database engines. Okay. When you connect MongoDB, the wire speaks the Mongo write protocol, so your apps believes it's talking to an actual MongoDB server, even though it's really using Cosmos DB under the hood. Yeah, it's okay. The Azure Cosmos DB API for NoSQL stores data in the document format. It offers the best end-to-end experience as we have full control over the interface, service and SDK client libraries. Any new feature that is rolled out, Cosmos DB is first available on the API for NoSQL accounts. Okay. NoSQL accounts provide support for querying items using the structured query language syntax. NoSQL accounts provide support for querying items using the SQL. What the fuck, man? Sorry. NoSQL. API for NoSQL. Uses SQL. Yes. It says NoSQL and uses SQL. The API for NoSQL in Cosmos DB uses SQL like query language, but it's not traditional ANSI SQL. There is how it works. Cosmos DB NoSQL provides a proprietary query language that looks like SQL, designed specifically for querying JSON documents. Okay, let's see. Select from blah blah. Interesting. API for MongoDB. API stores data in the document structure and via JSON format. It's compatible with MongoDB wire protocol, however, it doesn't use any native MongoDB related code. The API for MongoDB is a great choice if you wanna use the broader MongoDB ecosystem and skills. API for Postgres is a managed service for running PostgreSQL at any scale with Citus open source superpower of distributed tables. It stores data either on a single node or distributed in a multiple node configuration. Citus open source. What is this? Postgre extension that transforms Postgre into a distributed database so you can achieve high performance at any scale. with Citus, you extend your PostgreSQL database with new superpowers. Distributed tables are sharded across a cluster of PostgreSQL nodes to combine their CPU, memory, storage, and I/O capacity. References tables are replicated to all nodes for joins and foreign keys, or references tables nodes for joins and foreign keys from distributed tables and maximum read operations. Distributed query engine. Okay, I got it. Very good. It supports this. Uses this one under the hood. It's not like MongoDB then. Cassandra stores data in column-oriented schema. Apache Cassandra offers a highly distributed, horizontally scaling approach to storing large volumes of data while offering a flexible approach to a column-oriented schema. API for Cassandra in Azure Cosmos DB aligns with this philosophy to approaching distributed NoSQL databases. Okay. This API for Cassandra is Wire Protocol compatible with native Apache Cassandra. And that wire thing is not mentioned in the Postgres. Apache Gremlin. Cosmos DB API from Gremlin allows users to make graph queries and stores data as edges and vertices. Allows users to make graph queries and stores data as edges and vertices. Involving dynamic data, involving data with complex relations. Complex relations. To be modeled with relational databases. If you want to use the existing Gremlin ecosystem and skills. API for table. Stores data in key value format. If you are currently using table storage, Azure table storage, you might see some limitations in latency, scaling, throughput, global distribution, index management, low query performance. The API for table overcomes these limitations. Recommendation is migrate to your app if you want to use the benefit of Azure Cosmos. API for table only supports OLTP scenarios. Yes, this is very understandable. I think if you are using the storage, but storage has some limitations. Let's summarize those. Make table. The board multiple blah 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 blah. Protocol capability. Native Mongo Wire Protocol, Wire, all of them. Azure Storage Protocol. Azure Table Storage Protocol. Interesting best use case. New apps needs full distributed relational workloads. Existing Cassandra apps or workloads needs high write throughput. Complex. Connect data or graph-based queries. Okay, I like this table then. I'll put it somewhere. What is the title? APIs. Very good, very nice. APIs. I want to compare the storage table, storage, Azure. Compare Azure table storage with Cosmos DB table API. Okay, data model, key value. Scalability, limited scale, designed for single region. Azure table storage. Why do they say that? No single region now. Maybe some of them. I'm not. Yeah, can be single region. Globally distributed, elastic scalability, moderate performance, moderate higher latency under load, moderate low latency, milliseconds read guarantee, global distribution, not natively supported, full supported across multiple Azure regions, throughput, limited and fixed, indexing, primary key on secondary index and better quality performance. Strong consistency only. First 5 consistency levels. Replication local. Management, querying. Use case. Simple apps with modern need to single region basic. Make a research and gather more info about them and give me pros and cons, pros for each. Compare. Okay. Cost, storage based pricing, throughput based pricing, global distribution, query capability, basic query, advanced query, indexing, consistency, blah blah blah. Cost effective. Okay, high availability, simple management, integration with Azure services. These are not the correct comparison. Okay, we will do it later. I'm not satisfied with this answer. Okay, I know that in some cases the storage account is better than the Cosmos, but maybe I'm wrong. Huh? Maybe this was Q system. Yeah, whatever. Let's get this one for now. We can update this later. Discover request units. With Azure Cosmos DB, you pay for throughput you provision and the storage you consume on an hourly basis. Throughput must be provisioned to ensure that sufficient system resources are available for your Azure Cosmos database always. The cost of all database operations is normalized in Azure Cosmos DB. Cost of all database operations normalized, yes. Expressed by RU, a request unit represents the system resources such as CPU, IOPS, and memory that are required to perform data operations supported by the Azure Cosmos DB. The cost to do a point read, which is fetching a single item by its ID and the partition key value. Okay, for a 1 kilobyte item is 1 RU. All other database operations are similarly assigned the cost using RUs. No matter which API you use to interact with, the Azure Cosmos containers costs are measured by RUs. Whether the database operation is write, point, read, or query, costs are measured in RUs. Usage is expressed in RU. Memory, CPU, IOPS, requests, blah blah, read. One read. Read 1 RU. Insert 2. Upsert 2. Delete 2. Query multiple. Insert as well. Yeah, all of them. The type, not 2, okay? Let's read it. The type of Azure Cosmos DB account you are using determines the way consumed RUs get charged. There are 3 modes in which you can create an account. Provision throughput mode, yes, we already mentioned that. No, we mentioned dedicated and shared. This is the 3 modes in which you can create an account. Provision throughput mode, serverless mode, autoscale mode. In this mode, you provision the number of RUs for your application on a per second basis in increments of 100 RUs per second. To scale the provision throughput for your application, you can decrease the number of RUs and at any time in increments of 100 RUs. You can make your changes either programmatically or by using Azure Portal. You can provision throughput at container and database granularity level. Okay, you manually manage or use the throttle. In this mode, you don't have to provision any throughput. When creating Azure Cosmos DB account at any of your billing period, you get billed for number of request units consumed. Okay, there's no limit. Autoscale mode. In this mode, you can automatically and instantly scale the throughput of your database or container based on its usage. This scaling operation doesn't affect the availability, latency, throughput, or performance of the workload. This mode is well suited for mission-critical workloads that have variable or predictable traffic. Predictable patterns require SLAs on high performance and scale. Okay, actually, I couldn't quite grasp the difference between Autoscale and Serverless, to be honest. Between Autoscale and Serverless. Autoscale automatically adjusts your throughput up or down based on demand within set limits, ensuring consistent performance and SLAs, while Serverless charges you only for the requests you make without any upfront throughput, making it ideal for unpredictable or low traffic workloads, but with less guaranteed performance. Okay, now I got it. Then the autoscale increase with the number, but the serverless incrementally, probably by one, right? Let's see the table. Description, scaling, manual scaling, billing model, use case. Suitable for predictable workloads with steady traffic, ideal for intermittent or low traffic, best for variable or unpredictable. Guarantee, yes. Next, exercise. Create Azure Cosmos DB resources by using the Azure portal. I did it before, so maybe I can skip it. Availability zone, capacity mode, serverless. Okay. Data Explorer, new container, add your database, tick, next. Assessments. Which of the following consistency level offers the greatest throughput? Yes. Probably Eventual. Which of the following consistent level offers the greatest throughput? Throughput, the beneficiality, right? Throughput. It's bam bam bam. But strong is a bit slower. It's not asking for consistency level, right? Greatest throughput. I think it should be Eventual. What are request units? In Azure Cosmos DB, a unit of measurement used to express the cost of all database operations. All. A unit, yeah, actually all the database operations. A unit. Exactly, the measurement, a unit of measurement used to express the cost of, exactly, the unit of time used to measure the duration. No, not the duration. Storage used. Storage, no, not the storage. Let's see. Yes, we made it. Okay, I think we are done here. I hope you enjoyed or not. I don't know. I hope you enjoyed. By the way, but I don't care too much. Okay. But if you have enjoyed, then I hope there's going to be another one. You can enjoy more. See you later then. Bye. Bye.